All right, good day. Hope that you're doing good. So in this video, we're going to be continuing with the 2023 November question paper, right? So the second question, it relates to our waves. Now they say in the diagram below, right, you're given a transverse wave with a frequency of 1,5 hertz moving from left to right. Now, first they want us to define a transverse wave. Now let's look into the definition of a transverse wave. What is a transverse wave? A transverse wave, it is a wave in which particles of the medium vibrate at right angles to the direction of the motion of the wave. Now remember, you need to memorize these definitions. Why? Because they need to be exactly the same as the definitions you're given on your exam guide, right? So try to memorize your definitions because this is where you're going to get most of your marks, right? Because if you realize each and every question has a definition question. Now, moving on to 2.2, we need to identify or name the following. First, 2.2.1, we need 2 points that are in phase. Now, what do they mean when they say points are in phase? So points are in phase whereby, so 2 points would be in phase if they are separated by a complete wave, or one complete or one or more, right? One or more complete waves. So 2 points would be in phase if they are separated by one or more, right? So this is one or more complete waves. Now, if you could look at this, right? A and C, how many waves separate your point A and C? So this would be the first from here to here. This is my first complete wave. Now my second complete wave will start here up until my point C. Now A and C would be in phase. Why? It's because they are separated by two complete waves. Right. So for 2.2.1, we're going to say A and C. Now, what if we had another point here, which was Z? Is A and Z, or these points A and Z, are they going to be in phase? No. As you could see, these two are not separated by a complete wave. This is our half wave. So as a result, A and Z cannot be in phase. What if I had another point here, which is K? So A and K, they would be in phase. Why? Because your point A and K, they are separated by one complete wave. Now, let us move on to the other questions, or let's try and answer the other questions. We need to name the following point B. Point B, which is the lowest part of your graph, this is your trough. So your trough, it is the lowest point of your graph, and in this case, it's point B. So 2.2.2, point B is our trough. And what about point D? Point D is the highest point of our graph, and this would be our crest. So the highest point of your graph would be your crest. Now, moving on to 2.3, we need to determine the following: amplitude of the wave in meters. Now, what is the amplitude? The amplitude, it is the distance from your x-axis up until your highest point in the graph, right? This would represent your amplitude. Now, also same applies, is the distance from here to there. But remember, your amplitude should always be a positive value, right? So your amplitude should always be a positive value. Hence, we're going to make use of the distance from here up until the highest point of your graph. But the amplitude which is here is going to be equal to the amplitude here. Right now, because these two would be equal to one another, we are told that the distance from our lowest point to our highest point is 20 centimeters here. So meaning that dividing this by 2, this upper part, it will be 10 centimeters. The lower part would also be 10 centimeters. Right? So this would be 10. Same applies to this part. It will be 10. Now, I know that my distance from here up until here in terms of centimeters, which is my amplitude, so 2.3, I'm doing 2.3.1. In terms of centimeters, is 10 centimeters. And how did I go about doing that? I took the 20 centimeters and I divided it by 2. Now remember, my answer must be in terms of meters. Now, to move from meters, right, or rather to move from centimeters to meters, you need to divide by 100. So this 10, dividing it by 100, my amplitude would be 0.1 meters. This is my amplitude in terms of meters. Now, second question whereby we need to determine the wavelength. Now, how are we going to go about determining our wavelength? Now, first, what is your wavelength? Your wavelength is the distance between your crests or between your highest points. So these would be your wavelength. And also from here to here, this also represents your wavelength. Now we are being told that the distance from A to C is equals to 4 meters. So from A to C, it's 4 meters. So if I know that the distance from A to C is 4 meters, how would I be able to find the wavelength? So I would take my distance from A to C, so distance from A to C, and I'm going to divide it by the number of waves, right? Number of complete waves from A to C. Now, my distance from A to C is 4. How many complete waves do I have from A to C? So my first wave, it will be this, one complete wave. So I have one. The second one will start here, 2. So I have 2 complete waves. And now punching this into your calculator, your wavelength should be equals to 2 meters. So the distance between your 2 crests, it will be 2 meters. So I know that my wavelength, let me write it here, 2.3.2, my wavelength, I've calculated it as 2 meters. And I use this formula, the distance between those 2 points I'm given, A to C, divided by the number of complete waves from A to C, which were 2. Now proceeding to the next question. Now with regards to 2.4, 2.4.1 wants us to calculate the period of the wave. Now, what formula are you going to use to calculate your period? Remember, you're going to use this formula whereby you say your T is your period. It will be equals to 1 divided by your frequency. Now, 1 divided by the frequency of this wave we were given as 1,5 hertz. So I'm going to say 1 divided by 1,5. And punching this into my calculator, I should get the period of the graph. And the period of the graph would be equals to 0, rounding it off to 2 decimal places, 67 seconds. Now, the last question, the speed of the wave. Now, how do you go about calculating the speed of the wave? You need to make use of this formula for your speed. V, it is equals to frequency multiplied by your wavelength, which is indicated with a lambda. Now, our frequency, we know that is 1,5. And our wavelength, remember, we have calculated it as 2 meters. Now, as a result, the speed of the wave would be equals to 3. And because the speed has to be meters per second. And this would be all for this question. Now, on the next video, we're going to be continuing with question 3. Make sure you stay tuned.